thank you everyone for having us. So today we are here to present how Airflow 3 will make the process of building GenAI applications using Airflow even better. Like you can already build GenAI applications like we have mentioned in the keynote. In fact, in this year's Airflow Summit, there were 9 talks excluding this one about GenAI. So you can already do it, but the reason of this talk is what are we improving in Airflow 3 to help this support even better. So why are we doing this? Last year at the Airflow Summit in Canada, Julian and I gave a presentation about building and deploying LLM applications using Airflow, and we introduced Ask Astro as part of that and open sourced it as a reference implementation from our side to say, this is how you can build an Q&A applications using LLMs, and that was also for the community. So if you want to go to Airflow Slack and ask any questions to the bot, it will help you answer a lot of things over there as well. Or similarly, we have a web UI for that, ask.astronomer.io. So, but since then, this space is evolving so rapidly. A lot of changes have happened from that time itself. The pace of change, both in terms of like technology, new models, and just the emerging challenges based on those patterns, has just made us rethink of what we should do in Airflow 3. So there are some of the features over here that apply more generically to a lot of use cases, but will help GenAI even better. So what is the first change? A year ago, most of the teams were content utilizing API-based models like OpenAI's ChatGPT 3 or 4, which offered like convenience and the power of LLMs without having to worry about the infrastructure and stuff like that. And worrying about infrastructure is a big thing if you know about this. So, but as I said, the AI landscape has evolved dramatically. So we'll look at some of the trends over here first, and then we'll try to see what fits into which bucket. So the first is, we have seen the rise of or explosion of the new models. Every few weeks, there's a new model out there in the market. There's also an explosion of open source models, interestingly, like Meta's Llama, Falcon, GPT, Neo X, making it possible to deploy these large language models on your local host, local machines, or even in your company's VPC. And interestingly though, like Vikram and I have talked a lot about this, is like there's an explosion of SLMs as well, small language models, and that are very domain specific and very accurate and efficient for a small set of use cases. And most of us just needs that in the context of companies. So you really need to figure out what you want to use, where you want to use. Second, with the growing concerns around privacy and regulations, Jarek mentioned that in the keynote, a lot of regulations are coming, better be prepared for it. So with all those growing regulations, many companies want to make sure that they don't just pass any sensitive data to ChatGPT or any other models for that matter. So we need to make sure that you are really thinking about what data you are passing to those models versus what you want to deploy locally if it contains sensitive data. Third, we have seen major improvements in hardwares, but GPUs specifically, like thanks to cloud providers, AWS, GCP, and Azure, GPUs are very easily accessible now. Like GPU-enabled VMs, you can just click one button and they are there now. So they become very accessible. However, let's talk about everyone's favorite topic, money. GPUs are accessible. These fancy proprietary LLMs are very easier to access, but they come at a huge cost. They can easily burn holes in your pocket, more than probably what your favorite shopping app might do on a Black Friday sale. So you might want to think about when you utilize those sort of things. And as your organization scale your AI efforts, the real challenge is figuring out when to splurge money on what. Because for some use cases, you want to use that complex beast of a model, and the money is well worth it. But for some other cases, it's fine. You don't take your sports car to shopping, right? So just need to make sure where you want to utilize those things. Fifth is AI workflows. Because we have explosion of AI models, we constantly need to experiment. Your data scientists would want to experiment with new data sources. We did that for Ask Astro. We had like few sources of truth. We were ingesting Airflow docs and other docs, which I'll cover in a bit. But we want to experiment with newer sources of data and see whether it improves the answers, whether it does not. So there's a lot of experimentation that is needed. We want to try out OpenAI, GPT-3, GPT-4, other models and stuff. So there's an increasing need of experimentation, which always goes hand in hand with more options. And finally, AI workflows themselves are becoming more and more complex. In last 1 year, just literally 1 year, companies have started utilizing AI and LLMs for a lot more things than just chatbots, for sure. And we have got so many use cases within Astronomer itself and the community, and some of the talks you might have already listened to it. So with that complexity, you need to figure out, and you need to cater for different hardware environments, different multiple models. Some might be better for different use case, some might be for a different use case, so you need to figure that out. And given like these shifts, teams can no longer rely on one-size-fits-all solution. So based on that, we in the Airflow community are trying to figure out what are the options that we can give so that it becomes flexible for users, and rather than having to change a lot of user code, maybe drop in replacements or maybe just click of a button to change few things, provide better execution environment with Ash's task interface stuff, allow it to run at many places and stuff. So let's talk about those things. But before going on to those Airflow features, I briefly want to explain RAG, because someone told me just downstairs that, hey, it might be good to give some primer on RAGs. So I'll give you one example, and I'll tell you why I'm talking about RAG specifically over here. RAG still remains the hottest topic in LLM space, and there's a good reason for that. If you don't know RAG, it is a retrieval method used by AI tools, or whether you are using it, to improve the quality and relevance of your output. Like organizations want to utilize RAG because it makes those tools aware about enterprise data. Like ChatGPT does not have any context about your data. So, and you don't want to feed ChatGPT those answers. In some cases you might if it's not sensitive, but the way you will do that in a cost-efficient manner is via RAGs. Of course, you can fine-tune your open source models, but they come at a huge cost, which might be worth it for some cases, but not every case. So RAG is a cost-efficient way to do that. And when generating an answer without a RAG, models can only drop data when it was trained. So you don't see it nowadays with ChatGPT because it can now surf web browser on the paid plan, but otherwise it used to tell, hey, I just have data up till June 2022. I don't know anything after that. So for those sort of things, you can utilize RAG because you can add more recent data in your vector stores about that. So I'll talk about vector stores in a second as well. This is what typical architecture for Q&A use case using LLM would look like. First, as usual, you might want a lot of data because that is what you want to feed to your LLMs. And this data might be coming from various different sources. It would be articles, databases, web contents, docs on Notion and stuff. This can be structured, this can be unstructured. These documents need to be ingested, parsed, and it's not just one parser fits all. You might have HTML, you want to separate them out with HTML tags. You might have markdowns, you want to separate them out with headings and stuff. So you want to split them into smaller chunks, smaller relatable chunks. You cannot just split the data anywhere, otherwise the RAG won't be useful. You need to efficiently split them into smaller chunks, then embed or vectorize them and store in a database, which is vector store over here. This is the ingestion part. And the retrieval part is when you are asking the chatbot the question, first the tool should find from RAG saying, what are the most relevant documents related to this? It will pull those, embed those, and then send it to your AI model to say, hey, this is the question, this is the context behind this answer based on this information. And how would that translate into an Airflow DAG? So if you have a lot of data, of course, you can utilize dynamic task mapping for this so that you can run it on parallel. You don't want to run sequentially if you have 100 different S3 files, so you would utilize dynamic task mapping for that. Your data might be structured or unstructured, so you can use unstructured library directly if you are familiar with them, or you can use LangChain. LangChain is also very popular. With Python SDK or Python TaskFlow API, you can utilize LangChain over there to chunk those data. And then for vectorizing and stuff in Airflow, So last year, after that talk, we open sourced 5 different LLM providers and contributed that to Airflow, like Cohere, Pinecone, BG Vector, and few more. So we contributed them back to Airflow, so you can utilize them. There are first-class operators and hooks available, so you can utilize them to interact with those vector stores for embedding. This is what the Ask Astro DAG looks like from the non-code level. We currently embed data from different sources, like I mentioned. I just want to show that it can be structured, it can be unstructured, GitHub issues, docs, Slack messages, and then we utilize LangChain to split those into different chunks, and then pass it on to OpenAI, and then store them, to vectorize them, and then store them in the vector DB to then utilize them during query time. This is just the ingestion part. From the code perspective, this is how it looks like. This entire repo is completely open source, so you can take a look at this, clone it, adapt it as per your needs. I've given multiple talks about this in London as well, and most of the folks have utilized them to fit their own business cases and stuff, and it has worked well for them. And all of this are already done with Airflow 3, so why change anything, right? But even with Airflow and these recent trends, there are some challenges in the context of Airflow specifically, which Ash will explain. So over to you, Ash.
Thank you. So yeah, this is kind of all the history in the background. So kind of what are some of the challenges you might face when using Gen AI? Like a lot of this applies to Gen AI. A lot of this just applies generally as well. So it's kind of a universal. Python dependencies, I'm sure we've all had it at one point where it's like, I want to upgrade this, but I can't because that breaks and this dependent, you end up with this thing, like, but I'm not even using that, it's someone else in my organization. So you kind of got like dependency hell between tasks, and that just makes it annoying. Sadly, we are not in the times of free money anymore. So you can't just like have a GPU server running there with your web server. So yeah, you obviously want to be like mindful about what you want run where and only use the GPU for the task you actually need it for. And yeah, similar costs. New LLM models, providers, APIs come out pretty much every day, it seems like. So it'd be nice if you can go and easily switch between them and see which ones work better and go, okay, this week we want to use this one, we want to use Claude, we want to use Olama, et cetera, et cetera. Also, yeah, as kind of Kaxil mentioned, maybe you don't need a large language model, maybe a small language model is good enough. Maybe it's 2 language models in a trench coat, who knows? So how does Airflow 3 help with this? I should probably preface this next kind of section, the rest of this talk, with some of these we are working on, some of these are ideas, some of them may be bad ideas. Come and tell us. If you think that's great, if you think that's terrible, if you think we should rename it, please do. So yeah, let us know what resonates with you. So first off, task execution interface. I'm going to go through this quite quickly because it's now the 3rd time we'll be talking about it. But yeah. So Airflow 2, everything basically uses the metadatabase. It's your Postgres, it's your MySQL. That is the communication channel, that's the shared channel. Tasks have direct access to it. This has some performance impacts, mostly just the number of connections from running lots of tasks in parallel. Also, there's security implications. Any task can get any single secret in that database. That's probably a bad thing. So in Airflow 3, we are changing this. There is going to be an API in place. So workers, DAGs, tasks will not have direct database access. It will go by an API. There'll be a strong identity token for each task, for each worker, which means you can then audit. Like you can have, this is one thing Jenkins has quite nice, or whatever it's called these days. You can see like this workload, this task use this connection. With this feature, we can now build that same thing because we know exactly when it was accessed. By also breaking this up, rather than having a monolithic Airflow deployment, and you have to have that installed for your tasks to run, we have this task SDK, which will be a much smaller Python module. It's going to be a small module, a lot fewer dependencies, which means there's much more up to you as the DAG author to choose which Python modules you actually want. So that should hopefully mean like you can have one that runs, okay, I need PyTorch version 1.7 over here, and this one I want TensorFlow, and they for some reason they don't install together, but you just run them in different environments and makes that all much easier. Over to Kaxil.
Yeah, and like that solution can be utilized for GPUs, like I was mentioning in Keynote as well. You can utilize them to run certain things on GPU, and the normal task can run with Celery and CPUs as well. But Part two of the solution is we are thinking about a common.llm provider, but like Ash mentioned, please, if you have suggestions for a better name, come to us, because Jed mentioned that, well, it is LLM, but we are also talking about SLMs. What about that? So if you have good suggestions, please come and talk to us. Where do we want to use LLM? Where do we want to use SLM? Do we want to give the users the ability to choose for a single task that I want to select this or that? We don't want users to change everything just because they are changing a model. It should be like we have a fairly standard APIs for most of the models. So what we want to do with common.llm or whatever we come up with, if you come up with better ideas, let us know. But whatever the name is, what we want to provide is it should be easily interchangeable. The model should be easily interchangeable. You should be able to choose different models for performance or accuracy, complexity or cost, and dynamic selection based on certain criteria or requirement. This is a provider, so this is not strictly tied to Airflow 3, but we plan to work on this and release at the same time around Airflow 3 time frame. So task execution interface, common.llm, and the few things we'll talk about, cohesively they will make a better story, right? So in addition to like model selection, AI provider selection is equally important, right? Depending on the execution environment, GPUs, you might want to utilize CPU for heavier tasks like embeddings and vectorization, where you really want to span out your matrix calculation, whereas for data cleaning, data transformation, more IO-bound tasks, you want to utilize CPUs as much as possible. Those are technically a little lightweight operations. You don't need to use GPUs for that. So you can choose the right provider for the right job with this provider. And I'll show you some mock examples and we'll ask for some feedback as well. So let's show you that. This was our initial proposal. So if you remember and attended the talk last summit, we were asking for some feedback of what do we do about GenAI with integration. So the first phase of that was we will provide integrations for each of these services, Cohere, Pinecone, PJ Vector, OpenAI and stuff. That was the first phase, standard operators, standard hooks and stuff. The next phase was that, okay, now that we have all the hooks for them, we can probably provide a unified interface. You can consider this similar to like common.sql provider if you are familiar with that, where you provide the SQL query and a connection ID and it works out of the box. Airflow figures it out, the operator figures it out. So the idea over here is somewhat similar interface to be figured out, but you should be able to give a connection ID over here and say, hey, utilize this model, like utilize XYZ model from Microsoft model catalog or similar for Facebook and stuff. Utilize Llama 2 for this and stuff and provide source data set and target data set. And this will take care of embedding internally. You could, if you want, you could provide more parameters around chunking and all of that over here. So the Ask Astro DAG I showed you, there were a lot of few more things around chunking and stuff, which you can pass on as embedding parameters, and this will pass on to the client via the API over to whatever you select from that. So this is one option. The second option goes even further, and we might provide both options, which is like instead of a single LLM operator, we would say there is a single LLM ingest operator and there is a separate LLM inference operator, because those are technically two separate operations. So and an LLM ingest operator can look something like this, where you say embedding, do auto embedding, I leave it up to you, operator, figure out the best case. I will give you certain constraints. And that constraints can be like, hey, my selection criteria is I'm optimizing for cost, so the cost threshold should be minimum. Use GPU if necessary, so based on the input, based on the data source that you have, you can utilize CPUs if necessary. If it's a single file, you don't even care for that matter. If it's privacy sensitive, and here is where things get interesting. You can be explicit and say that, hey, I know that this task is processing sensitive data, so privacy sensitive equal to true, or you provide some sort of mapping where you say, if the data set is coming from this S3 bucket, please mark them as sensitive. We'll see how we can figure that out with data assets work that is happening. If we can pass on some metadata that, hey, this is sensitive data, we should be able to reuse over here that whenever someone is accessing this data, this is sensitive. So by default, do not use OpenAI's ChatGPT. Utilize the local deployment. So that is one of the ideas. So I am very open to hearing feedback, because we will open this up on the mailing list and stuff as well. And then you can give the embedding options. Like right now I have OpenAI, local, and Hugging Face, but as you know, Hugging Face is like hundreds and thousands of models. So you might be able to pass in the connection ID and say, figure it out, but then you will need to give the name of the model and say whether you want to utilize GPU or not. Cost, this is also an optimization we can do later on, which is where we have the connection, we know the APIs, we can just reach out in the operator, we can reach out to those service providers and figure out the cost and provide users some way to provide those thresholds. Again, this is yet to be figured out, but this is the second phase of the first phase of common.llm. So input, welcome over here. And that was the first part. Moving on to the second part of the story, which is ingestion is done, inference. What does inference mean? Inference from the RAG perspective is generation. You're asking a question and expecting an answer. So you need to generate, the LLM model needs to generate that answer. How will it generate? You will provide the data, you are utilizing RAG, you are utilizing data from the vector store, and then the model itself has its own answer. So the way to do it can be different. I'll give you the use case for a SQL assistant that Maxime talked about yesterday in his presets talk. So you can rephrase your question multiple times if you want, and you can play around how many times you want to rephrase the user input. And this is needed because sometimes us as users can ask the same sort of question in multiple different ways. So we rephrase the question, we can pass it on to the model and say, find the closest or the most related content from the vector store for all those three things, and just collect that information before you send all the prompt to the AI model. And once it's done, submit and get results for all of them and return results after that. Like after you submit all of this to AI, it will return results. That is inference. How would you do that with Airflow? This is an example based on Maxime's talk yesterday. He was probably not using Airflow, but it is easy to use Airflow. So you can imagine that there's a web editor where you can type in natural language saying, hey, bring me the sales data, top sales data of 5 locations in the last month. You'll provide natural language data, we'll go to the web API, the original prompt is reworded 3 times, and then passed on to the vector store. Now here is where things will get a little interesting, because how is the model supposed to know what data you have in Snowflake? It would just not know. So instead what you will do is you'll utilize RAG for that and pass on some of the data around, like let's say schema level information, column names, table names and stuff to GPT, saying, hey, if users ask anything stupidly, don't just try and make up queries. Say this table does not even exist. And it might be contextual as well. I might have certain permissions to tables. Ash might have certain permissions to other tables. So if I ask them and say, well, look for those tables that I have access to. So it can be very contextual and very helpful in this context. And then pass those information to OpenAI. Remember, this is just passing table names and schema, saying, okay, it has 5 tables. This is the table I need. Please give me the results. And then OpenAI can, let's say, connect to Snowflake, like create the SQL query, not connect to Snowflake, but create this query for Snowflake, knows the context, and then that you can utilize for platforms like preset to visualize and stuff. So this is how an AI SQL assistant might look like. And all of this is like, you can see, you can just easily orchestrate with Airflow, but there are certain challenges to that as well. Currently, we have mentioned like a few times that Airflow's execution date is a big constraint, because you cannot just run multiple DAG runs with the same execution date, which means that if I were to go back to this use case and there are 2 of us submitting the same query at the same time, Airflow can't run all of this pipeline. It will need some execution date difference. If it's the same DAG, Airflow will say, oh, unique constraint error, I don't know what to do now. So you just need to put 1 second offset, and that is, it can work, but it is clunky. So we would want Airflow to have a better experience with that. So one of the challenges like that, you cannot have batch triggered DAG runs, and experimentation becomes harder because you need to change few seconds here and there. You have no way to visualize those things. So possible, but very cumbersome and needs user manipulating the execution date. So we are calling it batch triggered diagrams, but you can call it anything. Dynamic model choice is the same duplicate of the first one, but here we are talking in context of inference. Even in inference, this is useful because you are utilizing different models for embedding an answer, so you might want the flexibility of choosing where these answers are coming from. So the same challenge like common.llm applies over here as well. Synchronous diagrams, which is like inference diagrams. Airflow currently does not have a way to return a result of a DAG, and which I'll let Ash talk about it on detail. But Airflow does not have the concept of DAG returning a data. It has the concept of task returning a data, and it works on the task level. So, Ash?
Yeah, so kind of ad hoc runs. As Kaxil was mentioning, you can kind of sort of work around this right now. But yeah, you need like a nanosecond difference. You can't have the same timestamp. This is kind of a personal pet peeve of mine. If you caught the opening panel on the first day, it's like, what would you like to fix? This. Kind of like the other way of thinking about this in a non-AI context is A/B testing. I mean, kind of like if you want to run the same DAG over the same data, you will be able to do that in Airflow 3. So it's like the same timestamp, same data interval. You're looking at the same data. You've just got some different parameters. Maybe it's different weights. Maybe it's a different model. And then we are going to think about some ways that you could like go and capture that in Airflow and then show it. So you can just like, in the Airflow UI, just like, okay, how do these two different diagrams at the same time perform, and just kind of look at them and yeah, so like kind of hyperparameter tuning, that's also called. Yep.
Yeah, I think with explosion of those AI models, right? You might want to experiment with a lot of different stuff, and all of that is possible once the execution. Let's say we remove execution date. It's possible, but okay, where are you going to look for? Are you going to look for logs for everything? It's like, okay, if I utilize this model, this is the accuracy I get. If I utilize this is cumbersome. So one of the features that was released recently in one of the 2x versions was the concept of data asset metadata. So you can pass in some metadata about data sets from within the task itself. So that's available in 2.10. What is not available is the UI experience built around it. So let's say if you are utilizing one model for experimentation, you can store that data, but in Airflow 3, what will be new is you will be able to visualize that data in the context of a DAG. So you can say, my inference DAG currently utilizes this model and produces this output. And over time, you can, let's say, kick off a job that runs it with 5 different models and say the accuracy of this is this, and over time, you can, if you select one, over time, you can see how it is performing for you. Add a new data source, you'll be able to visualize that. So this will help a lot in experimentation. What's coming in 3.0 as well is versioning. So it is not only DAG level versioning, which is great. DAG, we wanted DAG versioning from a long time. I wanted it from a long time. So that's happening, but there will also be data asset versioning. So all your assets that are generated will be versioned. So you can track that this is the experiment I did was with this version of the data, this was the data, this was the change, so that you can have a good auditing of all of those. So in the context of ML, you might say, okay, I'm training with some weights, I want to know the RMSE values when I change different parameters, or if you are utilizing, doing model retraining or fine tuning, you might want to do that and have a good view of that data. So you will be able to do that across different runs. And last but not the least, the synchronous DAG run.
So I think this is the one that we're least sure of the name on. One thing to make kind of clear as the first instance, when we say synchronous, we don't mean the API server is executing the DAG. It's not that. The DAG is still run in the normal way. This is kind of the use case we're thinking here is like, if you want to do an inference DAG and get the result back, how do you do that? We're not talking about like chatbot where you need super low latency responses, but there are plenty of workflows where it's like, I just need to run it, and if it takes 3 minutes or 5 minutes or 10 minutes, that's fine. So you can do this now. Sure, you can. You hit the trigger DAG endpoint, you get the DAG run ID, you poll for the status, wait until success, and then you, as the kind of caller of the API client, go like, right, okay, let me get the task. Let me go fetch the XCOM for this task that I know is the result I care about. That puts the impetus on you as the core of the API, and it's kind of leaking abstractions. So one of the things that we are thinking about doing is pretty much the last line down here where it says return LLM op. This is a way for the DAG author to say, this is the bit that's interesting of my DAG. This is what you should return to the core of this. This is all just an idea at this stage. So there's plenty of scope for changing this, for coming up with other ideas. But it's, yeah, it kind of put the emphasis on the DAG author to say, here's what people want. You can then have some cleanup. It doesn't have to be the last task either. Both with teardown tasks, you maybe need to pull some clusters down. Maybe there's just other processing you want to do. You need to, and it doesn't fit under the teardown, but it's here. And so the way this would work is very similar to kind of what I said before, with you calling individual endpoints as the API client, API consumer. But instead, it would just kind of be more one. So you'd submit a job, you get a job ID back, and you just hit an endpoint saying, is it ready? And it will say yes or no. And as soon as it's ready, it goes, here's your data, or here is a path to where you can get your data. But it just kind of, it's one API. It's a very standard, like, polling approach. Could also be streaming if we do that. But it's a, one API call, submit it, wait for the result. Is it ready? Is it ready? Is it ready? Here it is, without having to kind of do all this manual consumption yourself. So.
Yeah, and a good use case for that is one of our customers, their name is Laurel, and their use case is out on our website, but they utilize Airflow and AI for bookkeeping. So if you're a consultant or a lawyer, then you might be taking a lot of notes saying, okay, from 6 to 6:10, I was working on this because lawyers are expensive. My wife is one, so. But they need to keep track of time they spend on certain items, and their goal is to automatically keep this. Their goal is like, why tell the computer what I'm doing? It knows what I'm doing, so let's figure it out. But based on the context, if you're a lawyer, it has a different context, different applications that you use. If you are, as a consultant, software consultant, you are utilizing different things. So they utilize specific models per domain, per use case, and deploy it locally and say, okay, you must be spending time on here, 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 and automatically generate those things for you. So we think that they already utilize Airflow for this, but we think with this API where you can return results from Airflow itself, instead of building an API layer on top of Airflow that does all of this, you can just utilize Airflow that collects all the data for, let's say, last 10 minutes and runs the model and brings in the data and stores it. Because it is not a chatbot response where you just click it and expect a response immediately. This should be possible with, like, let's say, some latency, 5 minutes, 10 minutes. Our goal over time might change, and we might want to tackle even high latency problems, but at least this is a starting step towards that. So.
And this is also kind of one of the things I want to see for Airflow as we go forward is more use cases. If someone says, hey, I can't do this in Airflow, why not? Let's see if we can make it. Let's open up Airflow to be the orchestration for anything to do with data. That's kind of my long-term vision. And this is just one step on that journey.
Yeah, and a similar use case was like the mortgage applications, right? Like some of us are terrified with having AI mortgage evaluation, but it's being currently used. The companies are using it. So when you submit your application, there's a lot of things happening under the background where an AI is saying, based on whatever information you have, how likely are you to default or not default? And based on that, you are given a score and stuff. So we think Airflow can be a better solution around inference for that, because it's, again, you expect a response from your banks and stuff or money lenders in some hours, not seconds. So that's that. So how does this make sense in the evolution and stuff? So I had 6 bullet points or 6 blocks over here, right? So explosion of AI models, how would that be solved with common.llm, where you can change models independently, you can change infrastructure independently. How do we increase for data privacy and control within Airflow? Task execution interface is your answer for that. You will be running your task where your data resides. You can run it wherever you want. You can utilize CPUs for that. So even for the GPUs, you can utilize task execution interface for that. For cost optimization, again, the interface is common.llm. For experimentation, it is the removal of execution ID leading into ad hoc DAG runs and data assets work that will happen as part of Airflow 3. And last but not the least, like synchronous DAG runs will help in all the complexity of different use cases that we have that are not non-chatbot related. So in summary, many organizations are already using Airflow for AI applications, but we need your feedback as we add these capabilities in Airflow 3, and we are recruiting for building more Gen AI platform and use cases. So please talk to us and let us know. And I'm hoping that at next Airflow Summit, you guys can talk about how you utilize it for those applications. So that's it. Thank you.